What's up, everybody? Here is a set of problems that covers inverse trig functions and how we integrate using these functions. And the two things that I'm covering in this handout is that the inverse sine function, whose derivative is 1 over the square root of 1 minus x squared, and then the derivative of the inverse tangent function, which is whose derivative is 1 over 1 plus x squared. So let's go ahead and start with problem 1, which is asking us to integrate the function arc sine of x divided by the square root of 1 minus x squared. So automatically, when you see something like this, you realize, okay, this square root part is the derivative of arc sine. So the substitution you should make here is by letting u be arc sine of x. That way the du is 1 over the square root times dx, which is exactly this piece. So this piece that I circled here becomes the du, and that means that I can just rewrite my integral as integral of u, which is the arc sine, times du, right? So that's u squared over 2 plus c, and once I replace back the u, that's exactly 1/2 arc sine squared plus c. So that's the first problem. Let's move on to problem 2. Again, here in the denominator, we recognize the derivative of the arctangent function, but we have some extra stuff on top, right? If we had just looked at 1 plus just 1 over 1 plus x squared with respect to x, that would be just the arctangent function. But I have some extra variables here. So the way to do this is to split the fraction as 1 over 1 plus x squared plus x over 1 plus x squared, and then just integrate each of them separately. So we end up with two integrals. The first one is very simple, it's just the arctangent of x. And the second integral can be easily done by substitution, because we can see that the derivative of 1 plus x squared appears on top. Okay, it's off by a factor of 2, but we can fix that, right? So this integral here should be the same as the integral 1 over, this would be the u, and that's the ln of that piece. And now I just have to fix that factor of 2 that's missing, so I just divide by 2 here. And we can double check. When I take derivative here, I get 1 over 1 plus x squared times 2x, but the 2 gets cancelled by here, so it's just times a single x on top. So once I add these two together, that is the final answer for this integral. Let's do the next one. So we have problem 3, which is asking us to integrate something that now no longer has an x squared. But we can fix that, because if I let u be square root of x, what is x? That's exactly u squared. So I can fix that problem and try to make it look like an arctangent integral. So if I let u be square root of x, the du is 1 over 2 root x. So that if I solve for dx, that's 2 root x du. And again, since the u was the root x, this is the same as 2u du. Okay, and now I'm ready to rewrite my integral. I have 1 over u here. I have 1 over 1 plus u squared, that's here. And then the dx becomes 2u du. So I have it here, which allows me to cancel these extra u's, and that way I'm left with just 2 over the derivative of arctangent. So that's just, the integral of that is just 2 times arctangent of u plus c. And once I replace in the substitution that I make, where u was the square root of x, the final answer is 2 times arctangent of square root of x plus c. Next, we have problem 4. So this one now involves some trig functions, but the thing to notice is that I have 1 plus something squared on the bottom, right? So that automatically tells me that I should let the u be this cosine of x, which makes du be negative sine of x dx, So that means what? That my integral becomes 1 over 1 plus u squared, and this sine of x dx is negative du. So I put the negative sign in front here, du there, and that's the rewritten integral after I make the substitution, which is now very easy to integrate because that's exactly arctangent of u with a negative sign plus c. And of course, we could have also done it to say, because of this minus sign, the integral would be arc cotangent of u plus c, and that's another way to do this one, right? Because the derivative of arc cotangent is negative the derivative of arc tangent. So that is problem 4. Let's move on to problem 5. And this time now I no longer have a square on the bottom, but I have a fourth power, which I can easily turn into a square by simply rewriting it as x squared quantity squared, right? So then I make a substitution. U equals x squared, du is 2x dx, and that means that the original x with the dx becomes du. But I still need an extra factor of 2, so I added a 2 here, and then I also divide by that, so I'm not changing anything. And that means that my integral is going to be 1/2 here, integral 1 over 1 plus u squared, and then this whole piece on top becomes the du. And that's the rewritten integral once I've done the substitution. And now this is very easy to integrate. That's just arctangent of u times 1/2 in front plus c, and the u was x squared, so it's 1/2 arctangent of x squared plus c. And now for the last problem here, problem 6. Notice that I have the 1 plus x squared on the bottom that I need, but on top I have some extra stuff. But we can easily fix that by rewriting this fraction as 2x squared plus 2 plus 3, which gives us the 5 that we originally had here. And if I group it this way, when I divide 2x squared plus 2 by x squared plus 1, that's exactly that's just the number 2, right? So this integral is then the integral of 2 plus 3 over x squared plus 1. This is easy to integrate, that's just 2x. This is also easy to integrate, that's 3 times arctangent of x plus c, and that's our answer. So that's just a few examples to show you guys how to do some of these problems, and I'll put some more videos online with some of the other sections as well.